Good day to everyone. In today's video, we'll be looking at laser, and we'll talk mostly about laser and how it works. We'll also talk about the application and where it's being used. And lastly, we'll also figure out the advantage and the disadvantage of lasers. So let's get started. And please note that at the end of each video, there will always be an assignment which you are expected to submit the assignment the following day. Okay, so this video is released today, and I'm expecting you all to submit your assignment latest on Monday. Okay, so let's get started. First, let's quickly look at what a laser is. And in our previous class, I've explained to everyone that laser is an acronym. Okay, it's a short form. Okay, let me bring out my directional pen. So it's a short form. This laser you see is a short form, all right, which stands for light amplification by stimulated emission of radiation. So we are going to actually look at what all this really stands for and why is this a lot of grammar. But seriously, it is very easy and simple to understand. So when you ask meaning of laser, you just tell them it stands for light amplification by stimulated emission of radiation. Is a device that produces a narrow beam of intense and coherent beam of light of a single wavelength. Okay, that is what I show you. This a single beam of light which make it monochromatic. So we'll explain everything, what actually goes in, or what is happening inside this case is what we are really going to dive down in order for us to explain the amplification of the light, the radiation, the light quantum, and a lot of it. Okay, so let's get started. And like I said, if you have any question about this, kindly send your question to the school WhatsApp group created for this class, or even an outsider watching this video as well. Probably peradventure you are given the opportunity to look at this video and you have a question. I'll also leave a section at this box of this video on the website where you can also send your question, and I'll do my possible best to answer those questions. Question that who was the first scientist to first discover laser, then you should know the right answer now, and in what year. Okay, so here is a very practical example. Now you have your light bulb at home. Okay, your bulb, your globe. Okay, and here is a sample of a laser. Okay, now for the bulb, once you turn on your bulb, it produces wavelengths in many directions. Okay, so these are the wavelengths you can see in many directions. Let me try to get my so these are wavelengths, probably another color. These are wavelengths you can see. So it produces different wavelengths in many words, in many directions, and that is the reason why you will notice that when it's night or it's dark at night and you on your bulb, okay, you will notice that the whole house will be illuminated. All right, and the reason is because the wavelength, okay, of the bulb, for what I was saying. Now when we now compare a voltage of peradventure, we have a voltage of a light bulb of 5 watts, okay, or 5 watts of the same maker, and compared to a bulb of, let's say peradventure, 20 watts of the same maker, you will notice a difference. That means the brightness, and that's the wavelength. Okay, so the brightness will be differ. For example, if you're making use of AKT light bulb of 5 watts and of 20 watts, there's going to be a huge difference. Okay, that is, the area at which the 5 watts will cover will be lesser compared to the wavelength of the 20 watt of bulb. Okay, now these wavelengths are many, so they are not in one direction. But for laser can be used to lighten to illuminate a room. Okay, it is a one, it produces one wavelength, from the mouth here, and which is what you can see, thus one wavelength from the mouth, and which one of the characteristics you would always notice from a laser is monochromatic, because of a single wavelength which it produces. So in other words, once you are in a darker environment and you turn on a laser, okay, be it on of any power, of any voltage, it won't illuminate the entire building. Okay, but you will also notice that, okay, there is a reflection of light, there's a wavelength going through something, all right, but it will not illuminate the entire building, even though you use a very high voltage of laser. You remember in our physical class, I explained about how laser is used to cut metals for engraving. So I'll also show you pictures of that as we move ahead, so you could understand it better. So like I said, for the light bulb has many wavelengths, but for the laser has just one wavelength, and which is called monochromatic. Now you understand the meaning of monochromatic. Okay, so then the next feature is for the light bulb, it radiates in all direction. Okay, so just like how the wavelengths move from one point to the other, move in many directions, so the same thing applicable to the direction, the radiation of the direction. Okay, so it illuminates the whole environment. Now, but for the laser, the beam of the laser is direct, and that's why it's giving us 1 watt wavelength. So because it has a direct beam, are you with me? It's called what? Coherent. Coherent. It is coherent because it has a direct beam. But the radiation of this light bulb, okay, is incoherent because it is not directed in one direction. And that is the reason why I showed you some videos in our physical class whereby I explained that in order for you to laser, once you turn on a laser, it can actually burn a particular thing. And I think I showed you a video where the scientists try to use a laser with a fruit. Once you power up that laser, you could see how it penetrates into that fruit. You also make use of woods. Okay, I hope you remember that. All right, now, so with the help of the direct laser, make it possible to ignite any object. Okay, that is if it's a very powerful laser. Once you turn it on and you put an object, okay, not even though it's not even flammable object, you put an object, it will ignite. Okay, mostly if you try it with wood, it will ignite. So it shows you how powerful it is. All right, now moving on. Now let's now see what it really entails in that laser. What is really going on in the laser. Okay, so moving on to now here we have inside the laser. Now let's assume we've opened up the laser, that is the gadget. So let's assume this is the laser now. we now want to look at what it is inside. This is not a laser, this is just my graphics pen. Okay, so let's say this is a laser. Now we want to look at what is going on inside that laser. Okay, and this is why I actually brought this out for you. So inside the laser, a laser consists of a laser medium. Okay, which I will explain further. Now in that laser, before we talk about the laser medium, you could see all these small dots. So they are probably called a gas. Okay, more or less, mostly like a fuel. Okay, a gas. Now it now needs something to ignite it. Remember, let's go to your cooking. Let's go to the kitchen, in a sense whereby you went to the gas station to fill your gas, bring it into the to your home, and you try to, without igniting or add making a light flame to turn on the gas, you know you will not be able to have any source of heat. So the same thing applicable to laser. Now it already has a gas, okay, but it needs something to ignite it, and that is where we have a on and off switch which generates heat. Okay, it generates what? Heat. And now it says an energy source, pump, and two mirrors, one which is partially what? Transmissive. So this edge here, for every laser, will always have two mirrors, the first mirror and the second mirror. Okay, the first mirror and the second mirror. Let me show you a picture of what I'm saying here. I think I downloaded one yesterday. Now from here, now, like I was saying, a laser will always have two mirrors. So you can see the reflecting mirror. This is the first one, and this is the second mirror. So inside this place is where we have the laser medium that we were talking about, and here is the power supply. Okay, you can see the power supply. Okay, so it also has a lens, and this is the work pieces. Okay, so let's proceed to what we are doing now. From what I've just show you, so let's now see how what is really going on in this laser medium. Let's see. So moving on to the third page. Now in the laser medium, we have pumps and we have particles. Okay, we have pumps and we have what? Particles. So I try to make this as simple as possible for everyone. Now before we talk about the pumps and the particles, this is the energy that I was talking about. Okay, now when the pump, and you can see the pumps feeds energy into the particles and they rise to a higher level. Okay, so when this pump, okay, feeds the energy into these particles to an higher level, are you with me? And if these particles now, see, if these particles then fall back to their basic states, so after this pump has filled energy into these particles, and now these particles now fall back to its basic state, and that is where once it fall back to the basic state, a photon is released. Okay, so let me go back and show you something now from the diagram. So I'll just show you. I don't know if I can see it here. Let me see. View, increase this. Okay, so this is a very good example of what we are trying to say. Now from this, so once the particles feels the energy, okay, once the particles feels, once the pump feels energy into the particles, now the particles are in an excited state. Okay, so this is the particles now. Before it was in a ground state. So once the particles feels, the pumps rather feels the particles, okay, it feels the particles inside the laser. It is in a what, then it moves to what, an excited what state. Now if these particles then fall back to the ground state, a photon is released. And that's why you see from here, once it's come back here, a photon is what, a photon is released. Okay, now again looking at it here, so from the once the pump fill the particles, it gets to an excited state, to an high state. Then once the particles then fuse, comes back to the ground state, a photon is what is released. A photon is what is released. So let's say one photon is what is released. That is once this comes back to this state. Okay, now if these same photons now move to, or should I say match with another particles, and that's why you see I wrote here that, let me bring out my pen. Okay, so it says if any of these particles then fall back to their basic state, energy is released in the form of a what, of a photon. Can you see? Also called light quantum. If this photon then hits another excited what, particles. Okay, so now if this photon now hits another what, excited what, particles, where am I, then it is forced back into the basic what, then falls back into a basic state. So which means that if these photons now hit these particles, it's in an excited state. Now if these particles then fall back to the basic state, another photon is also released. Now so now that will be a what, a double what, a double photon. But hold on, something is about to be released there. Now this double photon, let's look at it. It is called, this is where we are now, right? Then it falls back into the basic state, releasing another photon. This is referred to what, is referred to what, stimulated what, emission. Stimulated what, emission. Let me reiterate again. Once your pump, the pump of the laser, that is after you've pressed the button, you've ignited the button, something goes on inside the laser medium. This pump pumps energy into the particles, taking it to what, an excited state, which I've showed you previously. Now once this particles rather now goes back to the what, to the basic state, a photon is released. Okay, now if this photon then move to join another particles, okay, in the excited state, okay, and these particles then fall back to the basic state, two photons will be released. Okay, two what, photons will be released. So one will be a replica of the other one. Okay, and that is known as what, stimulated what, emission. That is producing of what, of photons. Okay, producing of what, of more what, photons. Now if these photons hit another excited particles, that means if these photons now is hit another excited particles, it's take it to what, an higher state. Then once these particles then fall back to the basic state, okay, then you should know photons, that is 3 photons, will now be released. And that is how this thing goes on. So for this one again, now these photons also join these photons, add up to this what, to these particles in an excited state. Okay, and then once it comes back, other what, photons are now what, released. So this is how it continues to what, it continues to what, increase. It increases, whereby you will now have, we already have 4 here. From there we have what, we will now have 5 photons. From here we will have 6 photons. From here we will have a lot. So By doing so, these photons are now what being increasing, are now increasing. Now let's see the next slide. Now once these photons are now increasing, energy is repeated. The energy repeatedly pumped into the laser medium. As energy is repeatedly pumped into the what, the laser what medium, that is the source of it, where you actually what, you actually on the what, the laser. That means by not leaving your moving your hand from it. Okay, so the energy which is pumping, the energy which is you are using to pump into the what, those particles. Okay, those particles, remember inside the particles you have the laser medium there. Are you with me? Now it stimulates the particles so that they can release more what, more photons. So from what we've said so far, that when they pump energy into the particles, and the particles then fall back to a basic state, a photon is released. Once that photons hits an excited what, an excited particles again, and that excited particles then fall back to the basic state, two photons are now what, are now being released, and which leads to what we call stimulated what, emission. So reoccurrence of this what, of these photons, and that is how it generates. Now it increases the number of photons, and further and further a directional beam is what is formed. So from here now, once these photons are now being filled up with the help of this transmitted glasses, makes also help it to what, to move around. So by doing so, as this one is also happening, others are also what, occurring. Now it is moving from this direction. Okay, so it's moving from all this direction, like this. Okay, like this. So they are eating up, they are eating left, both this direction, like this, eating this direction. Now it is, once it get to this state, okay, it get to this state, it's what, there's a narrow beam, a narrow passage that actually what allow it to what, to come out. Then here you have the beam. Okay, this is a narrow passage, and here you have the what, the beam that now what, or should I say the lens rather, that now make it what, direct it to come out for you to see. Okay, so in a nutshell of what we just said, inside the laser there are things that is going on, and there you have the what do you call it, inside the laser you have the pump, you have the particles. Once they get to the higher state, a photon is released. Once the photon hits the what do you call it, the excited particles, then, and it gets to fall back to its basic state, double photons are what, being released. Now once this is still continue, that is once the energy is still, once you are still producing energy, you are still adding more source of energy. And here is a summary of it. Energy pump, okay, the excitation, energy from the light excites atoms to higher level. Okay, then the population inversion, more atoms are made to stay in the excited state than in the ground state. Okay, stimulated emission, when one excited atom returns to the ground state, okay, are you with me now, and emits a photon, that photon stimulates another atom. Do you get that? So it stimulated another atom in the world, in the higher state, to emit identical what, photon, in all phase and in the same what, in the same direction. Now you understand what we mean by stimulated what, emission. Now the amplification, now what does the amplification means? They emit photons, bounce between two mirrors. The emitted photons bounce between two mirrors, one fully reflecting and the other partially what, reflecting. So in that state where you have let me see if I can go back there. In this state where you have the stimulated emission, one is what do we have here? One is fully reflected, another one are partially what reflected. So one will fully reflect, the other one will what partially what reflect. These two, the process of these two coming out is stimulated emission, but when you're not looking at it, the reflection, one is fully, one is partially, and here's what we call amplification. Okay, I hope you are with me. Then this continuous reflection amplifies the light intensity, so it's enlarge it and make it what it's produce that light. Then the laser beam emission, a part of the light escape through the partial reflecting mirror as a laser beam. So as you can see, after these are occurring in the laser, so there is a narrow part whereby it needs to send out the photons. Okay, it needs to send it out so that you can actually see the light that is being escaping from it. All right, and there are different types of laser. There are some ones that are advisable for you to use, while there are some ones that are hazardous. Okay, so I don't know if probably you've noticed a conference meeting whereby they use a laser, okay, just like a torch, to direct their live stream, okay, so that people can follow, just like this. And I think I have one here also. It's more or less like something like this, whereby it shows you an indication of where I am. So okay, so but this is on the system, but that one is the physical laser that will be used to direct the movement of it. Okay, all right, then let's see, we're almost done. So the characteristics of laser. So what do you see before you could call that device a laser? Number one, check if the wavelength has just one color. So every laser has one color. Okay, is either red, blue, or green. Different colors. I mean, you might have other colors. It's not compulsory it does these three colors. Okay, don't get it twisted. Okay, you might have other colors, but whatever color it might be, it does be a single color. All right, so I hope you understand that now. The next one is the coherence. So light waves are in phase with each other, and which I've told you, we've explained in the beginning of this video. So highly directional travels in a straight narrow in a straight narrow beam, and that is why it is very intensive and not advisable to apply it on your skin or on your TV or anything you just want to test it on. So you have to be very careful, as if you are using a very powerful laser. So intense contains large amount of energy in a small area. So where are they used? Yes, they are used in the medical line. Okay, they are used for surgery, that is removal of tumor from the brain. And the way it happens, which probably I can actually show you a video of that in previously, how they do a brain tumor surgeries. They need to cut out that region. Okay, they need to cut out the region of where the tumor is, then do a surgery by opening up that place, not my head, by opening up that place and removing out the tumor, then stitching it back. But now with the help of the laser, they don't need to do that opening of of that part anymore. With the help of the light, it will kill the tumor cells. Okay, so, and which is mostly used in all very high standard hospitals. Okay, then in form of communication as well, I think I explained that to you in our physical class, that laser are also used in form of communication from one point to the other, in form of communication. Okay, with the help of the optic fiber, and that it will be our next class, the optic what fiber. So with the help of the light, okay, a medium is the optic fiber. Okay, and for example, you have let's say I'm actually live. Okay, I'm live talking to you. You are seeing me live. Something's really happening. There is a transfer of what of should I say of laser of lasers, okay, through a medium called the optic fiber. Okay, which transfer the the light into that medium. Okay, and let me use a better example. Let's see a CD now. You have a CD, okay, now, and you play it. Something happened inside the CD. The electronics has a laser that reads what has been stored on that CD with the help of the what with the help of the light. Okay, so for in terms of the communication as well, things actually happen with the speed of light. So, and that's why laser cannot be explained to the fullest without we talking about optical fiber. Okay, so which I'll be explaining in the next video after this. Okay, now in the industry, I want to talk about the industry in terms of cutting. Okay, which you will be seeing that video as well. Okay, melter plates, signboards that are being they use laser to actually cut. Okay, and in terms of welding, in terms of metals, they use it a lot. They also use in military to find a target identification. Yes, it's also used in science for orthography. I think I showed you. Most of you have watched Ben 10, or we've watched some film whereby they might want to communicate with themselves. Once it does flip up the watch, the person will just pop out from the watch, okay, in form of what of light. So it is possible as well. And electronics is used in terms of what of barcodes, okay, barcode scanners, okay, laser printers. That is, you know about printers. You've seen the printer in your school, whereby once you have that printer, I mean, once the print the we send we try to print from the printer using a code. Okay, what it does is it sends that light that is in form of digits 0101 into that cord. So that cord is a medium of more or less like an optic fiber. Okay, that transfer getting to the cord, it's in form of a light. Okay, so it passes through that cord, then go into the printer. Once it go into the printer, it converts itself into that 01 digit. Computers only understand what binary digits. Okay, so it converts it to that, and there the laser itself what do the work. And that's why you see, once you print out your paper from your printer, it is hot, right? Because what actually really happened there is a laser has been written on it, but it has a different intensity. Okay, remember I said laser are used to cut metals. So if that type of laser is being used for printing, then you'll not be able to print anything on your paper. So they actually reduce the intensity, but make sure it still works the way we need it to work. Okay, so it's making use of our toner, and that's why you see me using a toner to fill up the cartridge once the printer is uh the once the printer ink is down, okay, because the laser use that toner to write on that what, on that paper. So without the ink, it could not what, it won't write. All right. Then there we have barcode scanner. I believe you've seen a barcode scanner before in mall. Probably you went to a mall to shop, and you are at the payment section. You see them use sliding something at the back of the item you bought. Okay, what they actually done is, it's not a play issue there. What they've actually done there is quite simple. Okay, they've actually programmed it that, okay, for every item of this is sold for this. So once you pick one of those items, it has been stored on the system. Once you pick one of those items and the computer scan it, immediately it will bring out the price of that what, of that item. Okay, so that is another way they use it. And CD and DVD readers, yes, it's also used, in reading what, um discs. Okay, so a lot of things are going on in the CD. Once you put your CD, you want to watch your film, a lot of things are really going on there. Okay, the light is really reading the what, reading it out for you to see. So like I said, there is a lot to it, but nevertheless. So then let's see about the optic fiber. So the assignment is, number one, you need to define a laser for me. Number two, tell me the types of laser we talked about in our physical class, and also sketch out how a laser works. Okay, how a laser works. I can allow you, you are free to go online to get more image and work with it. So I will need you to actually have a sketch of this, and you have to submit this assignment latest on Tuesday. Okay, latest on Tuesday. I know some of you might be watching this video on Monday, so I will give you the grace to submit your assignment latest on what, on Tuesday. So let's say there's a particular aspect in this video you did not really understand. Yes, I am available to also what, help you out. So we are through with this our topic on laser, and the next one we'll be moving on to what, to fiber optics. And before we do that, like I said, I want to show you this. So why it's playing, I will just explain some things as well.
Laser lights are everywhere, from barcode scanners to cutting thick metal pieces for automobiles. We have also used lasers at least once in our lifetime, even if it was not as powerful to cut through metal.
So you can see what I'm saying here. Here is the switch. Okay, then you have the mirror. Okay, yeah, this is the beam. Okay, the narrow beam whereby it comes out from it. Okay, and you have the what do you call it, you have the laser medium. Okay, so let's continue.
How does the laser work? How do we get that straight beam of light? In this video, we are going to learn about the laser and how it works. How is it that powerful to cut through metal? And how we get that straight beam of powerful light moving in a single particular direction. Laser stands for light amplification by stimulated emission of radiation.
Okay, so here is another one. Let's try to just show you. So this is the medium I'm talking about. Then okay, so you can see once these photons move left and right, okay, they expand. All right, it expands. So I also leave the link to this video so that you can actually watch and understand it. Okay, so this is good. Okay, so let's see. So you can see this is it says here we have the reflective mirror, the first one and the second one. Okay, remember the diagram I showed you. So here in the 95 reflective, you have a O here, but this place is 100% was reflective. Okay, here you won't have any O. So it is from this place that the laser light will be coming out from. Okay, so just trying to fast forward it because of, and you have your switch. So it's just without you igniting the power, it's nothing will actually work. So once the power is ignited, then photons are being released. Okay, so here is another practical example. So let's say this is, here is what we have, the laser medium. Okay, the laser medium. So once the once the energy pumps pumps energy, sorry, once the energy, yes, the pumps energy into the particles. Okay, and these particles then move towards higher state. Okay, so once these particles then comes back to the basic state, a photon is what is released. So let me just show you that.
Those photon particles are absorbed by the
So
electrons present in optical materials like glass, crystal,
so you can
etc. When the electron absorbs the photon, it gets into an excited state.
so you can see, so once this energy is released from it, it's
Or
produced.
stimulated form.
So you can see, is once it's in the the ground state, it emits protons, but once it's in the higher state, it absorbs energy and comes back to the ground state to discharge the photons. So, and that is how it's
And jumps from one level to another level, but it cannot maintain that state, so it jumps back to the previous level.
so that is how it moves.
The photon particles that are exactly
So you
perpendicular
can
to the
see it
mirrors are
becomes
bounced between
2,
two mirrors.
becomes
When bouncing
4.
between
So
mirrors,
you can
they
see the
encounter even
mirrors.
more electrons.
So these
The
are the
same
mirrors.
process of receiving energy and doubling the photons
So
takes
it's
place again.
start doubling the photons,
When
as you
there are
can
enough
see.
photon particles, they penetrate from the mirror, which is
So
less
can you now
reflective,
see?
and that is what we see as the beam of
Can
light.
you see? So that's what we see
Is
as
the
what,
photon exactly
as the
perpendicular to
beam
the
of
mirror and
light.
bouncing? That's why we get a straight beam having only one direction.
All right.
The number of photons released from the beam will be directed.
So I don't know if you can actually listen to what it's saying, but I'll also leave a link to this video so that you can as well hear it yourself. But I believe at this moment now, you should have a better understanding of how laser actually works. Okay, so have a nice day. Please do not forget to actually submit your assignment. See you in the next video.